All right, good evening. Today we are going to have lab, and what we're basically going to do is implement stuff that I discussed in the lecture that I recorded last week, and we're going to fit a linear regression line to this x and y data, and basically we're going to use the least squares regression to fit a straight line to this data for the video lecture and on page 444. Basically chapter 17.1 in your book. We're going to get a line which is y is equal to mx plus b, where the slope m is this coefficient a1 can be computed from the data, and we derive this equation in the lecture, and the intercept can be found by this equation here, also derived in the lecture, where y1 is basically the mean, sum over the number of samples for y bar and minus a naught times x, and that same thing as the mean of x. And so what the first thing you want to do is take this data and put it into Excel, and I'll upload this data. And I want to show you how to do some things here to be able to calculate this. So essentially the things that we're going to need are, we're going to need n, okay? And n is going to be equal to the count of the number of data points, okay? So I just put count, and then I come down here. I can pick either the x or the y data, and I'll hold shift, and I'll highlight this. You can also do this with your mouse, and then I'll close the parentheses, and that'll give me the count. So I have n data samples, that's n, and here we want to do the sum of xi. And the way to do that is here we can just say equals, we'll do the sum, and we'll open parentheses, come over here with our arrow key, select all the x data, so that'll sum up all the xi data, and then we'll have our x bar, okay, which will be the average, and that's just equal to the sum over mean, okay? And of course, that's 95 over 10, it's 9.5. And then we'll do the same thing for yi. We'll say the sum of yi. Then over here, we'll say it's equal to the sum, open parentheses, come over here with our arrow keys, hit shift, select all the yi data, close the parentheses, and hit enter. And then we'll do y bar. And y bar is basically going to be equal to the sum, which we'll say equal, and then we'll come up and select the sum of yi, then we'll hit the / key divided by the number of data samples, which is n, which is up here, and that'll give us 8.2. So that gives us the sum of xi, sum of yi, the mean of x, and the mean of y. And so what we also want to do is calculate the sum of the product, okay? And the product is going to be xi times yi. So here we can say xi times yi, and we'll hit equal, and that's going to be xi. We'll go over here, hit the select the x data multiplied by the y data, okay? And then we can drag this down here, and that'll copy all the data. And you see each one is going to be up here. That's the sum of the xi. I mean, that's the xi and yi data. And then over here, we can say sum of xi times yi. Okay. And then again, that'll be just here. That'll be the sum of this data, just like we did for the x and y data. Hit enter. So that gives us the sum of xi times yi, and we also need the sum of xi squared, okay? So what I can do is I can come down here, I can highlight this row, and I can hit insert, flip those over, it keeps the same numbers. That's the xi squared, okay? And then here we'll just say this is equal to x data times we'll move our cursor over the x data again. So it's a2 times a2. That's xi squared. And we'll come down here and bring it here. And then this will be another variable called the sum of xi squared. Okay, so this is how we set up our regression. We basically have x and y data, and then over here we're picking all the variables that we need according to this equation here. So we got the n times the sum of xi times yi minus xi times yi over n times xi squared minus the sum of xi quantity squared. And we have our a naught coefficients. Okay, so we're basically building this equation here so that we can ultimately get an equation like this that fits aligned to the data. And these equations are derived in the video lecture that you guys have. Okay, so we have the sum of xi squared, and here we can just start to get our a1, okay, and it's going to be equal to n, which is 10, it's up here, okay, times the sum of xi times yi, which is down here, minus the sum of xi, which is here, times the sum of yi, which is here, okay? And we're going to put all this in parentheses, okay? So that when we divide by the whole quantity, and I'll go ahead and open and close parentheses here so that we can put the denominator in. And again, this is going to be n, okay, times xi squared, which is going to be this value, which I haven't populated yet, minus the sum of xi, quantity squared, which is the sum of xi, and it's going to be, we're going to put that in parentheses because just in case the sum came out to be negative, we'd want to square it. So we use the shift 6 to get the caret and square that data. And we're missing, right here, we're still missing this value, the sum of xi squared. So here we can just say equal the sum of this column, which is xi squared. Okay? So what we basically did is build that equation. And then we have a naught, okay? And a naught is equal to y bar, which is just this column here, y bar, minus a1, which is this one, times x bar, which is this one. Okay? So that gives us our coefficients. So here we can say, y is equal to mx plus b, and it's our straight line fit. So the next thing we need to do is see how our y estimate is. So it's going to be our y estimate, and it comes from our x values. Okay, we'll put this over here, and I'll just copy these x values down. X values are the independent variables. And we'll copy these down here. Okay, and then we'll say y is equal to a naught, okay, plus a1 times our x value, okay? And then we'll drag this all the way down. And here we need to hit F4 for to lock our a naught value and our a1 value, okay? And then we'll bring that all the way down. And you see these numbers are really close. So this y estimate is pretty close to this y value. This one is close to this value, and so on and so forth. They're all pretty close. And so what I've done is I've highlighted these values, and you can go in here and you can say insert. Let's see here. I'm going to do a chart. We'll do a line chart. We'll do a scatter chart. Basically, pick this one. This is a scatter chart with straight lines. Okay, and this is our data here, and these are our x values on the x-axis, and these are our y values here. And what we want to do is right-click, and we are going to say select data. We're going to add a series, and this will be estimated values. Okay, and the x values are going to be these same x values, but our y values are going to be these estimated y values. Okay, and so basically, there you have the linear regression, where this is the data here that came from this. The blue data is this XY data, and this data is the data that we got from our linear regression. So that's pretty much how linear regression works. And what I want you to do in this lab is pretty much go through this. And then time permitting, I'd like you to go through the information here and repeat it to get the standard error of estimate.